Hello dear. Welcome to this new tutorial dedicated to how a gas engine works. But before that, please hit like, subscribe and hit the bell button to give you more knowledge on how the engine works. The piston is one of the most important parts of the engine mechanism. For the single-acting gas engine, it consists, essentially, of a king cylindrical casting, closed at the top and open at the bottom end, having attached at an intermediate point a wrist pin which transits the thrust due to the burning gases, to the connecting rod and thence to the crankshaft. A piston performs three duties. 1. It transforms heat energy into mechanical energy. 2. It transmits the lateral thrust, due to the angularity of the connecting rod, to the cylinder walls. 3. It carries off some of the excessive heat generated in the combustion chamber. Early pistons were crude affairs, as compared with late designs, and the development is a result of the requirements becoming more and more severe to meet the needs of increasing piston speeds and higher compression pressures. The many types that have been produced may be classed 1.
With respect to the material, as A. Cast iron, B. Semi-steel, C. Aluminum alloy. 2. With respect to the shape of the head, as A. Flat, B. Crown, C. Bevel, D. Concave. 3. With respect to the construction of the skirt, as A. Solid, B. Split. 4. With respect to the numbers of rings, as A. 2, B. 3, C. 4, etc. 5. With respect to the clearance or fit in the cylinder, as A. Variable, B. Constant. 6.
With respect to the reinforcement, as A.
Single strut, B. Double strut, C. Wide strut. 7. With respect to the attachment of the wrist pin, as A. Stationary or anchored, B. Semi-floating, oscillating, C. Full floating. 8. With respect to the shape of the slot, as A. I, B, T.
In order for the students to understand the details of the piston construction, he should be familiar with the names of the different parts. These are given in figures 2 to 4, and the names of the various shaped heads in figure 5 to 8. The two main divisions of pistons are shown in figure 3, namely, the ring section and the skirt section. The ring section comprise the head, ring grooves, and so-called ringlands. It would require a sketch of the imagination to understand why designers and manufacturers call the portions of the ring section not cut away by grooves lands instead of bands. The skirt is the bearing surface of the piston, and supports the wrist pin bosses directly or indirectly. The piston skirt, except in some cast iron pistons, does not bear all the way around its circumference but only on an arc on each side of the plane of the wrist pin. These two surfaces are called the thrust faces. The remaining portions of the skirt are generally called the wrist pin sides. Piston requirements. The design of the piston is controlled, to some extent, by the design of the other parts of the engine, and this accounts section for the fact that all engines do not use the same kind of piston. One problem with respect to piston design is to produce a piston that will run with the minimum amount of clearance. Question: what is clearance? Answer: clearance is the amount by which a piston must be made smaller than the cylinder so that it will not seize. The different parts of a piston have different clearances. As later explained, the clearance here referred to is that across the thrust faces. Question: why is clearance necessary? Answer: clearance is to allow space for expansion of the piston and for a thin film of oil. Question: what kind of pistons expand the most? Answer: the piston expands the most is the aluminum alloy pistons. Comparing the expansion of aluminum alloy with cast iron, the coefficient of expansion per degree Fahrenheit per inch, according to Isidon, R 0.0000123 N for aluminum alloy, and 0.0000556 N for cast iron. The second major problem is to produce a piston which will permit the least amount of oil to pass into the combustion chamber. The problem has been handled by providing special piston rings to take care of the distribution of the oil, and additional rings to prevent leakage of the gases in the combustion chamber. Cast iron pistons. The trouble with cast iron for piston is its weight, being nearly 3 times as heavy as aluminum alloy. Moreover, it is not good as a heat conductor as aluminum alloy. Formerly, before engine speeds and compression became so great as now, the above properties of cast iron were not so objectionable. However, a heavy piston running a several thousand strokes per minute has considerable inertia. That is, great force must be applied to start and stop the piston at the ends of the stroke, resulting in excessive variation and greater stresses on the bearings. To reduce vibration and heavy stresses, attempts were made to make the piston as light as possible by the rib construction such as shown in Figure 9. The rib extending across the head and down the skirt were dependent on almost entirely for strength. An advantage of cast iron piston is that they have a rate of expansion the same as that of the cylinder and therefore can be fitted with minimum clearance. Semi-steel piston. The tendency in the construction of semi-steel piston is to get them very light. In fact, some of them weigh little more than aluminum alloy piston. Owing to the very thin walls of these pistons, they are lightly flexible and will shape themselves to the cylinder wall in which they are working. Accordingly, the piston's walls conform better to the shape of the cylinder should the latter wear oval. Aluminum alloy pistons. Modern automobile engines are high speed and the pistons have to travel up and down, that is, reciprocate, from a few hundred to nearly 4,000 times a minute. A weight moving up and down at such high speed requires a very great force to stop it and a very great force to start it on account of its inertia. The force due to inertia is transmitted by the connecting rod to the bearings, and it is the force which pounds against the bearings and produces vibrations. It is accordingly important that this force be reduced to a minimum, and that was the reason for the introduction of aluminum alloy piston, since aluminum is very light. To reduce the weight of cast iron pistons, they must be made very thin. While this might give the desired lightness, a thin piston offers so much resistance to heat flow that the piston would become unduly hot. Quicker acceleration is possible with aluminum alloy pistons on account of the reduction in weight. Another advantage that the aluminum is a much better conductor of heat than iron. Hence, the temperature of the head of the pile is lower than when made of cast iron. A disadvantage is that aluminum alloy expands much more than cast iron with rise of temperature. As a result, early aluminum alloy piston were made with considerable clearance so that they would not be too large at the working temperature. The result is piston slap. Piston slap. This knock is caused by the piston moving from one side of the cylinder to the other. It is a result of the forces acting on the piston under the influence of the angularity of the connecting rod as shown in figures 10 and 11. During the complete cycle, the piston travels from one side of the cylinder to the other several times. However, all of these changes are rather gradual except the one at the beginning of the power stroke, which produces the noise known as piston slap. It is not possible to prevent the piston moving from side to side of cylinder, but the noise due to slapping can be reduced by reducing the clearance. Since aluminum alloy expands when heated at a much greater rate than cast iron. This was not possible in the early solid skirt aluminum alloy pistons, but designers overcame this in an improved construction known as the constant clearance piston. Constant clearance pistons. It has been found that most of the heat which enters the piston leaves through the rings, and the temperature of the skirt is not high enough to account for all the clearance which was formerly necessary to give to aluminum alloy pistons. The skirt expansion was therefore due to two causes. 1. The expansion caused by the rise in temperature of the skirt. 2. The distortion of the skirt caused by the expansion of the much hotter piston head. By means of slots in the skirt, it has been possible to avoid the two effects just mentioned, thus producing a piston that will work with a greatly reduced clearance. Thus, by cutting a so-called vertical slot as shown in Figure 12, constant clearance is obtained with result that, when heated, the skirt expands circumferentially instead of radially, which the diameter of the skirt to remain constant. The horizontal slot at the top of the skirts partially isolates the skirt from the much hotter ring section and thus avoids distortion by the expansion of the head. By means of ribs connecting the head and wrist pin bosses, the load on the piston head is transferred directly to the wrist pin, thus relieving skirt of the load. Question. Define alumilliting. Answer. This is an electrochemical process which provides a film of aluminum oxide on the entire surface of the piston. This film is very hard and at the same time porous, permitting the retaining of the oil at the surface. It also materially reduces wear of the skirt, ring grooves and pinhole. Question. What are the advantages of tin plating cast iron pistons? Answer. It permits the tin to flow under abnormal temperature and pressures, thus reducing the tendency to seize with due clearance. Some of the tin is transferred to the cylinder walls, reducing the rate of wear on the piston rings and cylinders. Carbon adheres less easily to the tin surface. Question. Is the vertical slot really vertical? Answer. No, it is cut at slight angle. Question. Why? Answer. So that the edges of the slot do not work vertical with a sliding motion. Question. On what side should the slot be placed? Answer. On the minimum thrust side of the cylinder. Question. What is a campground piston? Answer. One ground slightly elliptical. Question. What is the object of chem grinding? Answer. It permits fitting with a close clearance across the thrust faces, eliminating rocking or slapping when cold. Question. What is the effect of rocking? Answer. It pulls the faces of the rings from the wall, thus causing leakage. Question. How is expansion taken care of in campground pistons? Answer. The campground piston being slightly oval, the small expansion of the thrust faces is provided for because the diameter at the edges of the thrust face is slightly less than it is across the center of the thrust face. Question. Is the clearance of a piston the same from top to bottom? Answer. No. Theoretically, a piston should be ground tapered from the bottom to the top, but commercially it is ground straight from the bottom of the skirt to the ring section. The least clearance is given to the skirt section. Question. What portion of the piston has the greatest clearance and why? Answer. The top of ring portion, because here the heat is greatest and accordingly the expansion also. The smallest diameter of a piston is at the top and the largest at the bottom. Collapse of the skirt. One of the principal causes of piston slap and high oil consumption with split skirt alloy piston is due to the increased clearance caused by collapse of the skirt. To remedy this, piston expanders are sometimes used, one type being shown in Figure 14. Figure 14. Sealed Power Company adjustable piston skirt expander. It has spring tension, may be regulation to compensate for variations in piston and cylinder wall wear. Successful results are possible with piston expanders if they permit adjustment of the skirt diameter so the correct clearance can be obtained, if they expand the skirt for its full length, and if they be resilient so as to prevent seizure. Chem grinding. The elliptical shaping of the thrust faces pistons, commonly referred to as chem grinding, is intended to compensate for expansion. The shape given the piston approximately follows the shape of the regulator cam of the machine used to finish the piston. The regulator cam is attached to the machine in a manner to control movement of the piston toward and away from the machinery tool or grinding wheel so that an elliptical shaped skirt contour is generated. The cam grinding machine as usually constructed provides for the table of the finishing machine to rock to and from the grinding wheels as the cam revolves synchronously with the piston on the driving spindle of the machine. Question. What is the nature of the contact of a cam ground piston with the cylinder walls from cold to hot? Answer. It is variable. Question: how does it vary? Answer: Campground pitons have a minimum cylinder contact when cold. The contact increases as the temperature rises due to radial expansion of the skirt in that portion given abnormal clearance by the chem grinding. This abnormal clearance is shown in Figure 19, and the progressive increase of contact with the cylinder walls in Figure 20 to 22.
T-slot pistons. This type of pistons as shown in Figure 23 and 24 combines the features of solid and split skirt. That is, the vertical slot is not extended all the way to the bottom of the skirt. The term T-slot is derived from the resemblance of the two slots to the letter T. As shown in Figures 23 and 24, the horizontal slot is placed in the lower groove or near the top of the skirt according to fancied result aimed at by the designer. Drilled holes are placed at the ends of the slots to prevent possible splitting due to stress set up by expansion. The maximum thrust face is complete with the piston hood and is not slotted. The expansion characteristics of this piston differ somewhat from other pistons. Question: how does the upper end of the skirt at the major thrust face expand and why? Answer: it expands with the piston hood because it is attached to the hood. A short distance from its point of attachment, the skirt begins to expand mechanically. The mechanical expansion increases in effect to the bottom of the skirt on the maximum thrust face. Question: what is mechanical expansion? Answer: forced expansion of one part due to the thermal expansion of another part to which the first part is attached. Question: how does the upper end of the minimum thrust face act? Answer: the T-slot permits this face to expand similar to a split skirt. Question: how does the skirt expand below the end of the vertical slot? Answer: this solid portion of the skirt is subjected to mechanical expansion or so-called hat banding. Question: what is hat banding? Answer: in the case of the T-piston, when the maximum thrust face of the skirt is forced to expand by the thermal expansion of the hood to which it is attached, the solid portion of the minimum thrust face contracts in the same way a hat band would along one axis when expanded along another axis at right angles.
Hat banding is illustrated in Figures 28 and 29. Question: on account of hat banding, how would the unsplit section of the skirt act when ground round? Answer: it will blind in the cylinder. Question: how is this avoided? Answer: the unsplit portion of the T-slot piston is Campground. Question: explain the effect of chem grinding the unsplit portion of the skirt. Answer: it permits the skirt to absorb by contraction appreciable excess pressure imposed at the thrust faces when coming into contact with the cylinder wall simultaneously. Question: what is the chief feature of the T-slot piston? Answer: the unsplit lower portion of the skirt eliminates the possibility of collapse. Question: what is another feature? Answer: the T-slot piston gives quick wear in during the running-in period of new car. That's all, guys, for the meantime. Part 2 of this piston tutorial shall follow, so please don't forget to hit the like, subscribe and hit the bell button. Thank you.